Hey everyone, this is Bhargav Suthar, and we are continuing the topic set theory. Now, in previous session, we discussed what is the set, what are the types of describing a set. The first one is the roster method, and the second one is set builder method. Also, we discussed what is a subset, what is a universal set, what is a null set, means all the types of sets we discussed. Also, we discussed how to represent a set via Venn diagram, and also we discussed the operations on the set. Now, in this session, we will discuss some examples based on the figures or Venn diagrams and other examples. Now, let us discuss the first example. Using Venn diagram, show that A union this B bar intersection C equals to A union B bar intersection A union C. Now, see, we can prove this by other method also, but here we have specifically asked that we have to prove it by Venn diagram. Okay, now first, let us draw what is B bar. Here there are total three sets. Now the B is the second one. Now what is B bar? Means except B, all the portion. That means the shaded part, that is the B bar. Now what we'll calculate next is B bar intersection C. So what is B bar intersection C? Now see this in this figure, the shaded part is B bar. Now intersection with C. Now where is C? Now this portion. So what will be B bar intersection C? That means this portion and this portion. So there it is. This is B bar intersection C. Now A union this portion. That means here this is whole A. So what will be A union B bar intersection C? It will be this one, this and this shaded part. So it will be like this. Okay, so A union B bar intersection C. So for left hand side, this is the resultant figure. Now, if we get for right hand side the same figure, then it will be proved. Now for right hand side, we will calculate first A union B bar, second figure is A union C, and then their intersection. Now we've already drawn or calculated this B bar, so that means A union B bar. So A union B bar. See here the shaded part is B bar. Now we want to union it with A. So what will be the part? This is whole B bar is there. Now with A, that means this portion. So like this. So here this portion is A union B. Okay, now next, A union C, that is very easy. Now A union C, that means this is A and this is C, so it will be A union C. Now we want to calculate the intersection of these sets. So that means the intersection of these figures. So what will be the intersection? So I think, see here, except this portion, everything will be there. So the next figure will be like this, and you can see that both the figures means both the resultant figures are same, so we are through. Now let us discuss some basic identities. Let capital A, B and C be any subsets of set X, capital X. Then the first is idempotent laws. So what is idempotent law? A union itself equals to A itself, and same way A intersection itself is A itself. Second one, commutative laws. Now A union B equals to B union A. That means you can change the order of the set and the result will be same. Next, same way in the intersection, A intersection B is B intersection A. Next, distributive law. Here, A intersection B union C. So, as its name suggests, A intersection B union C. That means we will distribute into two parts, like this: A intersection B. This will be in middle. Union A intersection C, and in same manner for A union B intersection C equals to A intersection C union B intersection C. Okay, next, De Morgan's law. A union B whole dash. That means A union B whole complement. That will result into A dash intersection B dash. And in same way, for the reverse part, A intersection B whole dash. That means A intersection B whole complement equals to A's complement union B's complement. Next, absorption law. A union A intersection B. It is A. Its name suggests absorption. That means A absorb this whole A intersection B and it will result into A. And in same manner, A intersection A union B. So here A absorbs this A union B and that is A. Now next, double complement. That means A dash of dash. That means complement of A and its complement. That will result into A. Now see, we can prove all this by simple arithmetic, but in this lecture we won't calculate it. Now, cardinality of a finite set. Cardinality of a set is number of distinct elements in a set. Cardinality of a set, suppose the set is A, then it is denoted by small n of A or this modulus of A. It is denoted by like this, n of A or modulus of A. For example, we have a set this. This is the set builder form. A equals to set of all x such that x is in between 2 to 10 excluding both. So how many elements will be there? So here x is in between 2 to 10 excluding 2 and 10. So I think there will be elements from 3 to 9. So how many are they? They are total 7 elements like 3, 4, 5, 6, 7, 8 and 9. So 7 elements are there. So the number of elements in a set, that is a cardinality. So that means this cardinality of A is 7. Easy. Now this one is very important. Principle of inclusion and exclusion. Now for two sets, the cardinality of A union B is same as cardinality of A plus cardinality of B minus cardinality of A intersection B. And in same manner for three sets, if we have three sets, cardinality of A union B union C, and that is same as cardinality of A plus cardinality of B plus cardinality of C minus A minus B's intersections cardinality. That means cardinality of A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus cardinality of A intersection B intersection C. We will use this in examples. Let us take example. Question is, consider a set of integers from 1 to 250. Find how many of these numbers are divisible by 3 or 5 or 7. Also indicate how many are divisible by 3 or 5 but not by 7. So first, let capital A, B and C. Here we will use principle of inclusion and exclusion. Let capital A, B, C denote the set of integers from 1 to 250 that is divisible by that A is divisible by 3, then 5 and 7 respectively. That means for A it is divisible by 3, for B it is divisible by 5 and for C it's divisible by 7. Now what we want to find, how many of these are divisible by 3 or 5 or 7. So first, what is cardinality of A? That means 1 to 250 numbers are there. Now A is divisible by 3. So that means how many numbers will be divisible by 3? So it will be this integer part of 250 by 3, that is 83. That means cardinality of A equals to 83, and it means that out of 1 to 250, this 250 numbers, there will be 83 numbers which will be divisible by 3. Yes, this, this bracket denotes integer part of A. That means this 250 by 3 is 83.3 and that is simply 83. Now in same manner, what will be cardinality of B? That is 250 and B stands for divisible by 5. So divide by 5 and that is 50. So that means out of 250, 50 numbers will be divisible by 5. And same way, a cardinality of C, that is 250 by 7, and that is 3, 5, 13, 5. Now, what will be a intersection be? So that means how many numbers are there which are divisible by 3 as well as here it is n. So divisible by 3 and 5. So that means 250 divided by 3 into 5 because we have here n. So that will be 16. So that means out of 250 numbers, 16 numbers will be there which are divisible by 3 as well as divisible by 5 both. That means both. Same way A intersection C, that will be 250. For A it's 3, for C it's 7. So 250 by 21, that is 11. Now B intersection C, that is 250 by B stands for 5 and C stands for 7. So that is 7. Now A intersection B intersection C, that means divisible by all the three numbers. That means 250 divided by 3 into 5 into 7, and that is 1. So that means only one number will be there which is divisible by 3 and 5 and 7, and that is it will be 2. Now, by principle of inclusion and exclusion, this is for three sets. We know that cardinality of A union B union C, that is, I'm just simply saying mod A plus mod B plus mod C minus mod of A intersection B minus mod of B intersection C minus mod of A intersection C plus mod of A intersection B intersection C. Now we have calculated almost all the entries. Like A union B union C, it is 135. Therefore, that means if we put all these values, we will get 135. So this is the answer of first question. That means that what was the question? Uh, how many of these are divisible by 3 or 5 or 7? That means 3 or 5 or 7. We have calculated all these entries. So if we substitute the values, we will get 135. Now what is the next question? Also indicate how many are divisible by 3 or 5 but not by 7. So now divisible by 3 or 5 but not by 7. So just consider this figure. Divisible by 3. So that means this A portion, or divisible by 5. That means this B portion but not by 7. So that means cancelling the C portion. So we need to calculate this shaded part, and that is divisible by 3 or 5 but not by 7. So how to calculate? This portion is actually this cardinality of A union B union C, that means this whole 3 minus this cardinality of C. We are subtracting the cardinality of C, and we've already calculated what is A union B union C, that is 135, and cardinality of C is 35, so it is 100. So that's last example. Among 1000 students, 32 study maths, 20 study physics, 45 study biology, 15 study maths and biology, 7 study maths and physics, 10 study physics and biology, and 30 do not study any of these three subjects. Find, what is the question? The first one, the number of students studying all the three subjects. Okay. And second one, the number of students studying exactly one of the three subjects. Okay. So what is the solution? Now here there are total three subjects: maths, one, physics, and biology. So let us just denote it by ABC. So let ABC denote students studying. The first one is for maths. That means A stands for maths, B stands for physics, and third C stands for biology, respectively. Now what is the given data? We'll just write it into symbolic form. Now, cardinality of X, that means how many total students are there. So among 100 students. So that means cardinality of X equals to 100. Okay. Now 32 study maths. So that means cardinality of A, it is 32. 20 study physics. For physics, we have taken B, so cardinality of B is 20. For biology, we have taken C, so cardinality of C is 45. Now, 15 study maths and biology. Maths and we have and. So maths and biology. So for maths and biology, that means A and C. So intersection, cardinality of A intersection C is 15. 7 study maths and physics. So cardinality of A and B is 7. And same way, cardinality of B intersection C. So that means B intersection C. So physics and biology, and that is 10. Now, 30 do not study any of the three subjects. Now, A intersection, sorry, A dash intersection B dash intersection C dash, that is 30. How 30 do not study any of the three subjects. Now, do not study. So that means A dash, B dash, C dash, like any of the three subjects. So we have taken intersection. So that is 30. Now, for first, we have to find the number of students studying all the three subjects. Now, A dash intersection B dash intersection C dash, that is cardinality of X minus A union B union C. Okay, so what is A union B union C? Cardinality of A union B union C, that will be 100 minus we have this, that is 30, so it will be 70. Now first, for the number of students studying all three subjects, so we have this, that is the principle of inclusion and exclusion. We have calculated almost everything. This is uh, this is 70 and this are given in the question. So the number of students studying all the three subjects. So that means we have to find this cardinality of A intersection B intersection C. Just substitute the value and we will get it 5. Now second, for the number of students studying exactly one subject. Okay. Now the number of students studying only maths. We will just calculate all three. So that means for only maths, only physics, and only biology. So this will be the figure, like studying exactly one subject. So here just see this shaded part. Here this portion indicates studying only maths. This portion indicates only physics, and this only biology. So for only maths, what would be the formula? This is the cardinality of A. This whole, just consider this whole A. So that means cardinality of A. Now we want to we will subtract it cardinality of A intersection B. That means this portion. So we have already subtracted. Now we want to subtract this portion. So that means A intersection C. But see, by subtracting A intersection B and A intersection C, we have subtracted this middle portion twice, but we want to subtract it only once. So we will just add it, that portion. This middle portion is A intersection B intersection C, and that is, now just we will just put the values. So 32 minus 7 minus 15 is 5, and that is 15. In same way, number of students studying only physics. Now again I'm explaining. Now for only physics, that means the shaded part. Now this is cardinality of B. Okay, now minus, we want to just subtract this portion. So minus cardinality of A intersection B minus cardinality of B intersection C. But by subtracting both, we have this subtracted this portion. That means A intersection B intersection C twice. But we want to subtract it only once. So we are just adding it, this A intersection B intersection C is cardinality. So it will be 8. And in same manner, for biology, it will be like this, and that is 25. But we want to find the total number of students studying exactly one subject. So that will be the total of all the risks. That means 15 plus 8 plus 25. So that will be 48. So that will be 48. Thank you.